Hi, everyone, and welcome to today's OpenJ9 community call. Off the call today, we have Alex, who will be giving a talk on the Metronome GC. Um, Alex, would you like to start by sharing your screen?
Yeah, let's start. Okay, can you see it now?
Yeah, we can see your slides.
Okay, I guess should I go full screen or something? Maybe something like this. Okay, so as Dan mentioned, this is a quick talk about the Metronome GC policy in OpenJ9. I'll have probably slides for 15-20 minutes, so I'll skip over some of them, so that later at some point people can read more thoroughly. First, let me just start with GC policies that we have available in OpenJ9. I'm not going to elaborate on them. I'm just going to say that GenCon is our default GC policy. It's kind of a good compromise between throughput and low pauses. And I'll be comparing at some point the Metronome with GenCon. So Metronome is specific for very low pause times, and if you really want to control, if you want to have a more stringent control over the pauses, then this is the most preferred GC policy. There are some other ones like opt-average pause. You can also control pauses, but Metronome is the most strict one. On a high level, what you can see is that there are GC cycles occasionally that are scheduled, and they run for some time, something like 10% of the time they're active. Depends really on application heap sizing. They appear from a high level, they're concurrent with the application, but as a cycle. But if you zoom in into one of these cycles, you will actually see that there are stop-the-roll increments that when GC runs and they interleave with applications. So either GC runs or application runs exclusively. They just appear from high level that they are concurrent. So these pauses that are by default 3 milliseconds long, and we have a strict control when they run. So scheduling of these increments is strict, and you'll see a little bit more of details. But the point here is to kind of guarantee the GC overhead, so we don't have too frequent or too long of these increments. So basically, we kind of guarantee the throughput of an application is not going to be compromised over some limit. There's some scheduling of this GC things that are manual or static. Like, for example, the start of a GC cycle is static. It will trigger when heap is 50% full. So we have to do a little bit of experimentation at the beginning and tuning when exactly, if this is a good default point. If you set it too high or too low, you may end up with a waste of memory, or you can actually have a GC not complete incremental session, and then it will complete in synchronous GC with one last increment that is longer than 3 milliseconds. Anyway, if you tune it and set it up properly, everything should be incremental and with these low pauses. Scheduling of the increments themselves are very strict. So in such a way that in any 60 millisecond window in an active GC cycle, we guarantee to have at most certain number of increments. By default, this is 6. So basically, we guarantee it's going to be at most 30% of GC overhead in any 60 millisecond window. All these parameters like duration of an increment, or the window size, the throughput guarantee 70%, or all these things are configurable through command line options. So you can tune, and reduce the GC overhead, for example, to 80%, sorry, 20%, or guarantee the throughput to 80%, but that will cost you then heap footprint. You have to provide larger heap. A little bit of a technicality about an underlying technology. This is a simple mark and sweep collector. Marking is concurrent. It's based on a snapshot at the beginning area as opposed to incremental update. I don't have time here to go into details how it works. This is well-known style of a collector. You can find it external literature, but the known facts, I'll just remind you that this is a preferred collector if you want a better pose control, because there is no like card cleaning phase, for example, that incremental update has it, but it also has comes with the cost that right barrier of the snapshot at the beginning is a little bit more expensive, and there's more floating garbage because all new allocated objects are kept alive. All these during the GC active cycle. Another interesting thing is how the heap is organized. It's actually region-based heap. And the most interesting and most used one is regions for small objects. So all objects are grouped in size classes. So regions all have all objects with approximately similar size in the same size class. There are 15 size classes with a logarithmic scale from 16 bytes to 2 kilobytes. The next one type of a region is a raylet type region. So basically you'll see a little bit more details on the next slide, but all arrays, any array that are larger than 2 kilobytes will be discontiguous. We separate or like split them into arraylets, and then we can put them in the special regions. There is a third type, large object, but it's really, really infrequent or possibly never happens, really. Those are scalar objects larger than 2 kilobytes. Motivation for this organization of the heap is dual. First, we control better, we have better control of fragmentation, because this is just a mark sweep collector. We don't move objects, there are no compactions, but it's also easy to control sweep in incremental / concurrent fashion, because you can, for example, sweep one region while application thread is allocating from another region. Raylets, as I mentioned, discontiguous organization, representation. Array that are less than 2 kilobytes will be just treated as a small object, but if they're larger than 2 kilobytes, they will split. And then what we do here is we introduce array of these leaves at the beginning close to the object header. So there's basically, if you want to access, if a thread wants to access an item in an array, there's going to be a level of indirection. You have to first define the leaf it belongs to, and then index the leaf themselves. And finally, what are the performance expectations, or what are use cases for this GC policy? So it's recommended to use if you really want to, if you're really worried about the worst case post times, or if you really want to look into response time distribution. It should normally improve the 4.9 or 5.9 percentiles, while because of the throughput penalties, it will compromise the lower percentiles. Rough expectations is maybe the throughput will be around 30% lower than the GenCon's GC policy throughput, but it will highly depend on the really application behavior, because this is non-generational collector, very generational workloads will probably suffer a little bit more, but non-generational workloads will maybe suffer less. An example of non-generational workload is, for example, transactions that preserve a session, for example, call, that have a state that lives for a long period of time. So that rate of the objects is not that high. Tuning is possible, so you can for example, increase the region size, relate leaf, various parameters about scheduling. So you can decrease this gap a little bit even more, less, and again, there are ideas we can improve this, but your feedback is welcome, so we know what to focus really on. That's it, so if there are questions.
Thanks so much for giving the talk, Alex. Can you mention again, the kinds of workloads you would typically want to use Metronome for?
Yeah. Okay. So I'll repeat just two bullets here. So like very generational workloads, with a high allocation rate and very low survival rate is probably not that good, because with the very large nursery and and infrequent nursery, you will probably be able to decrease the pauses, of the local collects. But if there is a survival rate is relatively high, then non-generational workload, sorry, the generational GCs are probably losing its benefit. So if your workload has, for example, characteristics of a session, so you create a session, it lasts for several seconds or sometimes minutes, and then you tear down a session. That means that there are objects that are going to live around for several seconds, several minutes, and that means it has non-generational characteristics, so those things are a relatively good candidate for reducing or maintaining a relatively low gap relative to generational collector like a Genco.
Okay.
We have a question in the room here. Thanks, Alex, by the way. Wonderful presentation.
Hey, Alex, it's Kim. Just wondering, the distribution of object sizes, is that something that's predetermined for each application, or how is that arrived at?
Sorry, you'll have to repeat the question. Last 10 or 15 seconds, there was really a bad.
We're having some network difficulties here, I think. The distribution of object sizes, is that predetermined per each application, or how is that determined?
That's static. That's static. Actually, that's one part that you cannot control. It starts in 16 bytes, and roughly each class size is, I believe, I forgot, 25% larger than the previous one, up to 2 kilobytes. So something like 100 bytes is size class and 125 bytes. Although they're certainly 8 bytes aligned, but they're 25% apart.
Have you ever considered using a buddy system, like a binary buddy or Fibonacci buddy system to deal with that? You get the same, I think, the same goal, controlling fragmentation. You get about 25% internal fragmentation typically with binary buddy. Have you ever considered that?
Yeah, certainly those variants are possible, yes.
Great, sounds like a topic for beyond this call. Thanks.
Are there any other questions? All right. Thanks again, Alex. We really appreciate you taking the time to give us this talk. And at this point, then, I think we will move to the next piece of our agenda. Just going to check. Is Boris on the call? Okay, no, I don't see him. I was hoping to get an update on the RISC-V Dynamic Languages Summit. So I guess we will move on. Are there any other questions from the community for OpenJ9 that All right, then I will turn it over to Arena to take us through the summary of some of the work items.
Okay, so we have the same number of issues as last week, and we have a small increase in PRs. Well, small but somewhat relevant. So we went from 78 open to 87 open, and everything else is the same. So yeah, that's all I have to say. It's a small increase in PRs. And
Is there any trends within that small increase? Is it largely showing up across the board or in any particular area?
no, I don't have anything specific, and there is a discrepancy between the PRs in the components and PRs, the overall PRs. So I'm not able to localize right now, like within a minute, where they are. So no good conclusion can be done at this time, but I'll get there next time.
Irina, just to clarify, are you saying PRs as in issues as opposed to pull requests here?
Yes. Well, not issues. So we have 269 issues. We have 87 PRs open. Yes.
Okay.
All right. Are there any other questions on the issues? Okay. All right, moving on to machines then. I'm just checking to see if Charlie's on the call. I don't see him, so I guess there's no update on UNV machines yet. Are there any other areas machine related that we should be discussing or should be bringing up at this point?
Just a quick question then for the Windows machines, the OpenJ9 Windows machines, have those been?
So how's that information available?
Violetta is working on the other three, and she, at the same time, she was trying to upgrade number 1 because it was missing a security update for Visual Studio, and unfortunately, it got rebooted. It hasn't come back yet, and we were waiting on Tim to reboot it because he owns the, I guess it's SoftLayer account. So
yeah, Tim's around in the office today, so I'll try and chase him up if he hasn't done so yet.
Yeah, and I saw your note, Adam, in the Slack channel. Maybe we should figure out if there's a way to have a couple people have that ability to reboot because
for the AX ones, we actually used a functional ID to create them, so that would be preferable. But
yeah, I think it might be a bit more.
I'm not sure if we can transfer them.
I got the impression that was a little bit problematic at the moment because it was linked to Tim's credit card number or something like that, so he didn't want any sort of access to his account.
No, he didn't want to share that information.
That's a great idea. You can put my name on that.
But yes, in general, yeah, you're right, and that's obviously the best solution going forward is to have multiple people able to do it.
Okay. At least there's a known reason why they were created under his name.
I just want to add a big thank you to everybody who's been involved in setting up these machines. It's very much appreciated. All right. Moving on to the builds and platforms. The JRE packages, the issue is open at adopt. I have not had a chance to check that yet, so if anybody else has an update on the status of that, it'd be appreciated. Opening it now, it looks like it hasn't been touched for a little bit, so I suspect that we'll need to step up and help there if we want to see this make progress. The next package is the large heap, the non-compressed refs packages. Thanks to Teresa and Adam, I believe these are almost ready to go in the OpenJ9 pull requests. We should be able to get that merged in the next few days, I suspect. Adam, is that fairly accurate?
Yeah, I think it's pretty much ready. There was just one test failure in all the extended builds when I ran it yesterday. So hopefully that's either a quick fix or maybe we can just ignore it now, or maybe exclude it.
All right.
Are you running the test or is it a subset?
Sorry, Shelley, that was a little scrambled.
Sorry, Sanity Functional is green and then it has the one failure.
Okay. And then you presumably are seeing some tests being skipped because some modes have compressed ref or no compressed ref as a command line option, right?
I didn't look that closely, but
okay. I'll take a look after. I'd like to know how many tests actually run. Thanks.
It didn't look like many tests from when I ran it.
Yeah, that's what I was thinking. As many of you know, we have variations of tests that run. And if one of the variations, or what used to be called modes, has compressed ref or non-compressed ref, no compressed ref in the option list, those tests will just be skipped. So we may need to look at adding some variations so we can test these builds.
so according to TestNG, there was about 2,000, and in the TAP results, there was 222, 90 skipped, and 1 fail.
And that compares to the other builds. I don't have the numbers in front of me, but I guess I'll do a comparison.
I haven't compared.
Okay, thanks.
We also have the Win32 binaries that we're working on. Cheng has been doing some work there to make sure it builds on Win32, working through a couple of minor issues, and then it will need to approach adopt about building Win32 on JDK8 as well. So. Seeing some good improvements in platform coverage and mode coverage here. So, and I have no update on the macOS binaries. I just haven't been able to get back to that branch. So. All right, moving along in the agenda. The end user experience. Are there any areas in this particular section that we need to discuss today? Shelley, I know you've created the blog. Have we started with an inaugural post on that yet?
Yeah, there are 2 posts on it, and later this week, a group of people will be getting together to lay out a plan for content rollout, including a series called Lightning Talks. So if you could share the MP4 or the video files or point me at them, we'll take excerpts out of this meeting recording to grab the Lightning Talk stuff and create posts around each one of the talks. The other thing I think we'll want to do is start to lay out a series of talks around each component. So we'll be reaching out to team leads and team members to start drumming up some content from each one. I know we have a few in the queue from test, and I think you know, some of the other teams already had expressed they have content they'd like to share. So we just need to start chipping away and rolling it out. There's no actual hard deadline on any of this. I'd like to make sure we try to keep the content fresh. So we'll set a goal for ourselves and see if, we can get something happening once a week or once every 2 weeks at minimum.
Sounds great. The conversation on the wiki, as far as I'm aware, there's been no further discussion there. For the Wikipedia entry, Sue, have you had a chance to take a look at that?
No, I haven't had any chance to look at how you go about doing that yet.
Okay. So moving on to the 0.9 release. The release plan, I believe I saw in the Slack channel that our 0.9 release plan has been approved at this point. And so now it's a matter of finishing off whatever testing we need and making sure that the features we have planned for this release are all ready to go. So I think we're starting to get towards a better shape for this. Is there any other updates on this particular area?
We have the milestone, which is full of a number of issues that haven't been closed yet. It's right above where you're typing.
Thank you. All right, so we have the milestone there. Yes, we will have to focus on closing out those issues over the next little bit. Anything else that anybody wants to bring up in this area? All right. As we're nearing the, sorry, go ahead. As we're nearing the end of the call, I'm going to ask if there's any other business anybody wants to bring up at this point. All right, then why don't we call it now for this week? Thank you to everybody who's attended, and thank you in particular to Alex for giving us the lightning talk on Metronome today. The next meeting will be next Wednesday at the same time. Thanks, everybody.
Great, thanks, bye.